Alright, we're going to look at solving quadratics using square roots. Now, we've done solving quadratics with factoring, and that's not going anywhere. This is another method using square roots. Method works really well when you just have the squared, the quadratic piece, and a number. So we got a few different examples up here, and we'll look at some more. But in each case, you see quadratic number, here's that quadratic square, and just numbers. Okay. So when I have this, I want to make sure the quadratic is isolated. In this case, it is. So to use square roots, our main rule for equations was we can do anything we want as long as we do it to both sides. So what I'm going to do is square root both sides. When I square root the x squared, I get x, and when I square root the 9, I get plus or minus 3. Because negative 3 squared is 9, so is positive 3 squared. So my two solutions, plus or minus 3, you can write it with the plus or minus, or you can write it with a comma in between. It doesn't matter which one comes first, whatever you're most comfortable with. Another way that'll help you remember there's a plus or minus. There has to be two solutions that powers 2. It's going to tell me how many solutions there are. So that'll help me a little bit. Number 2, a little bit different setup. I've got x squared plus 10 is 0. So the main difference here is that this guy's not alone. Okay? I need to isolate that x squared. I need it to be alone like it was in number 1. So I'm going to move that 10 over. So I'd have x squared equals negative 10. Now it's alone. I can look at taking that square root now. So if I square root both sides, I'm going to get an x on the left. And here comes my plus or minus. Now, I know that I can't do the square root of 10. Well, it's a decimal value. It's irrational. But there's a negative in there. We need to remember from our past, that's an I. That's an imaginary number. So it would be I root 10. Or you could write root 10 and then I on the back side of it. But I've got to make sure I get the I out of the radical. And there's my plus or minus. Again, if you want, you can write it separate like we did the first one. Number 3, I added another little element here. And that's the 3 sitting in front. Still, I need that x squared alone. That's my goal. I've got to get that guy alone. So we're back to just some basic operations. I can move the 12 over. 12 there. Divide by 3. It gives me a 4, and now it's back looking like this very first one we did. Square root both sides. So x would be plus or minus 2. There's my two values for that. So get a couple more looks here going, but we have our basic. We need to isolate, and sometimes it takes 2 steps to isolate. Sometimes we get something that is a nice perfect square. We can square root. Other times we can't, but there's that imaginary showing up. We have some different looks there. Okay, now we've got 3 other ones up here. First one looks a little bit similar to what we had in number 3. Then we definitely get some different looks in 5 or 6, but we're still using that square root method, meaning I want that quadratic alone. So I'm wanting to get that x squared alone. So similar to number 3, I've got to move the 5, divide by the 4. So if I do those 2 steps, I've got 4x squared equals negative 5. And if I divide by the 4, I end up with negative 5 4. So I don't end up with a whole number. That's okay. All right, we end up left with a fraction. We can still take the square root to get from x squared down to x. So when I do the square root of a fraction, top and bottom are independently. So the bottom, square root of 4 is 2. I can do that one. Square root of 5, that's irrational. I can't really do that. But I can pull that I out, root 5i over 2. And again, I've got my plus minus for my two values. I've still got my two values. I from the negative, couldn't do anything with the 5. The ones we've seen so far, a couple of them anyway, we could actually do the square root. I could on the bottom. Okay. So a little different look on the answer, but pretty similar right there. 5. This is still a quadratic, and it is isolated. I know it's still a quadratic because I see the square. I want that quadratic isolated. That was the purpose in getting this x squared alone back in number 4. Well, now the quadratic is alone. Since it's alone, I can square root both sides. Plus minus in there now. Square root of that squared gives me x plus 3. And the square root of 16 is 4, so I'd have plus or minus 4. Now this is going to add another step to it, because for me to get x alone, I need to subtract the 3. That's the only change that's happened here. So I end up with negative 3 plus or minus 4. Now this is a case where I can't just leave the answer like this, because I can actually do it. I can do negative 3 plus 4 is 1, and negative 3 minus 4, negative 7. So again, negative 3 plus 4, that's giving me the 1. Negative 3 minus 4, that's giving me the negative 7 for my two values there. 6, when you look at it, it's kind of like number 5, except that 4 is on the wrong side. So I still need this quadratic isolated. So I'm going to move the 4 over, and I know it's a negative 4, so by now you realize, well, that's going to produce an imaginary. So if I square root both sides, I end up with just the 2x minus 1 on the left. Square root's going to take out the square. And then I'd have plus or minus 2i over on the right. Finish this one out. I would have to add the 1 over. So remember, we want this guy alone. We're still trying to get x alone. So 2x. 1 plus or minus 2i, divide by 2, x would be 1 plus or minus 2i all over 2, and I can actually split that up. If I split it up, I would have 1/2 plus or minus i. If I split it up, the 2's would cancel. 2 over 2 is 1. Notice it's in that complex format we talked about in a previous section, where we want the real number first and then the imaginary.